Welcome back. Explosions can be caused by nuclear reactions, high explosives, or a combination of dust, mist, or gas in the air, or also by other oxidizers. And both dust and gas explosions are very similar in the nature, and when a volume of flammable mixture is ignited, it results in a rapid pressure increase and fire moving through the atmosphere or cloud. In detail, a dust explosion occurs when a combustible material is dispersed with the air, forming a flammable cloud. This allows the flame to propagate through it, while a gas explosion follows a very similar principle when a gas and oxygen are pre-mixed with explosive limits, which depend upon the supply of oxygen and the concentration of the fuel. And good to know that if either of these is too high or too low, then explosion will not occur. In order to understand the mechanism of explosion, we need to clarify some terms like deflagration and detonation and the explosive atmosphere. An extremely dangerous situation will occur if a large combustible mixture of fuel and the air is formed in a cloud and ignites. And the time period from the release of fuel mixture in the air through to ignition can range from few seconds to tens of minutes. Also, the amount of fuel involved can also vary. As well, the pressure generated by explosion's combustion wave will depend on how fast the flame propagates through the explosive mixture and how easily the pressure can expand away from the cloud, which is governed by confinement. And you shall know that when a cloud is ignited, the flame can propagate in two different modes through it. These modes are deflagration or detonation. The most common mode of flame propagation is deflagration. During deflagration, the flame front travels at subsonic speeds through the unburned gas, and the typical flame speeds don't reach higher than 300 meters per second, and the pressure developed in front of the flame explosion may reach values of several bars. In contrast, the speed of travel of the flame during a detonation is supersonic. As in a fuel air cloud, a detonation wave will move at speeds of between 1,500 and 2,000 meters per second, and the peak pressure in front of the flame can reach from 15 to 20 bar. And actually, this pressure front, when enclosed, can cause substantial damage, including the collapse of the structure. Also, you shall know that if the ignition source is from a weak source like a hot surface or a spark, the explosion will initially start as a slow-burning deflagration, and due to obstructing objects and confinement, the deflagration can accelerate and become fast-burning. And when a deflagration becomes sufficiently rapid, a sudden transition from the deflagration to detonation may occur. And if this transition occurs, a very high pressure loads up to 50 bar can be reached locally and severe damage can be expected. And actually the possibilities of transition to detonation will mainly depend on the type of fuel, the size of the cloud, and the enclosure conditions, such as the obstructing objects and confinement. Here's the end of this lecture. Thanks for watching and see you later.